Okay, so last time what I looked at was what is the force on an object due to another object. So we had to generate the field from a sphere. I'm going to look at generating a field from a plate. We're going to pretend we're somewhere in this region because technically there are fringing fields like this that happen and all sorts of nastiness. But if we stay somewhere in this moderate region like that, we'll be okay. So this is going to be 100 by 100. Then we'll come up here about 10 centimeters, which is actually a lot closer than that. If that's 100, it's really right there towards the center of the plate, and try to figure out what the field is there. To do that, we'll use E equals KE, which is actually 1 over 4 pi epsilon naught. I don't know why I changed my mind about which one I use. Sigma over 2. So that's going to be what our field looks like. The thing is that we don't know the sigma. We know the charge and the area. So we're going to have to do some other work, right? So that sigma is equal to the charge over the area. Not a big deal because the charge is 10 times 10 to the minus 6 coulombs, 10 microcoulombs. And the area is 100 centimeters by 100 centimeters, which is 1 square meter. So that just means 10 times 10 to the minus 6 is 10 to the minus 5 coulombs per meter squared. So that's not a really horrible thing, but that's how you get your surface charge density. We talked about that in the last lecture, two lectures ago, something like that. Okay, so now we have this. We can bring that in here. Remember this KE, which is equal to 1 over 4 pi, 14 pi, 4 pi epsilon naught, is also equal to 9 times 10 to the 9th Newton meters squared per coulomb. Sigma is 10 to the minus 5 coulombs per meter squared. And then 2 has no units, so we'll just divide through those things. That's 4.5, right? And then we have 10 to the 9th times 10 to the minus 5, so 4.5 times 10 to the minus, or 10 to the 4th. Let's see, coulombs squared. One of those coulombs drops out. Newtons per coulomb, which is 45 kilonewtons per coulomb. And there's a mistake there. Okay. That's newtons per coulomb. Let's see. So, yeah, in order to use this to find this, because this is the correct way to find that, I had to find the surface charge density. This was the same as the D2, or assuming this is an insulator or something like that, it's completely charged, it's completely uniform, just for our purposes. And once I find that, I can just put that in here and do a little bit of math and end up with 4.5 times 10 to the 4th newtons per coulomb, or 45 kilonewtons per coulomb. All right, so that's number 2. So after 2, we do 3, and after 3, we get lunch. All right, so I'll talk to you later.